Hi, Dr. Second Chance. We're back with another episode of math help for the ASVAB if you're going into the military, and the GED if you're working to get your GED. Today's topic, area of quadrilaterals. Area of quadrilaterals. What's a quadrilateral? Something with four sides. And so there are four types of quadrilaterals that you need to know for this test. A square, a rectangle, a parallelogram, and a trapezoid. And we're going to talk about those and how you calculate the area of each of these. And I just want to reiterate, these are not usually difficult to do, and it's an easy way to guarantee you get a correct point or mark for that question. There are more difficult area questions that can be asked, and as part of a general strategy, if you look at them and you have no idea, it's better to not spend a lot of time and to go on to another question that you can get. One of the ways that people do poorly on the math exam is that they take way too long trying to figure out a hard question when there might be another 10 easy questions that they could have got to and got correct. And so I will show some easy area questions for quadrilaterals, a few difficult ones for quadrilaterals, but if it's looking too difficult, then by all means, just skip it, guess an answer, and move on to another question. So let's talk about a square. Quadrilateral, square, four equal sides. Let's say the length of that side is A representing a number. The area will be the formula A squared, or A times A times A, or A squared. And remember that the answer for an area is always in square units. So for example, if A happened to be 4 feet, and this side down here is also 4 feet, that would be 16 square feet. So the answer on the test might put 16 feet, which case it's wrong because the correct answer is 16 square feet. And so always be looking not only for what the number is, but for your answer, but also that you have the correct units, The next quadrilateral, or four-sided figure we're looking at, is a rectangle, like a football field. The area for a rectangle is the width times the length. The width times the length. And so I wrote it here, length times the width. And again, the answer is in square units. And so if the width was 20 yards and the length was 40 yards, that would be 20 times 40, or 800 square yards. Remember, square units for the answer. If it was 800 yards, that would be incorrect. Again, you have to have square units when you're talking about area. So a square is one side times the other. A rectangle is also one side times the other, but these two measurements are different. This can be 5, 5, 5, and 5. This can't be 5 and 5 for a rectangle. It'll be like 5 and 7, or two different numbers. So we're going to look at another two types of quadrilaterals that you may be asked on the test. One is called a parallelogram, and one is called a trapezoid. Now, looking at the parallelogram, The reason it's called a parallelogram is because it's made up of two sets of lines that are both parallel or that will never touch. So there's a line here and a line here that is parallel, and a line here at an angle and a line here at an angle that's parallel. So two parallel lines coming together, forming this four-sided geometrical object, and this one's called a parallelogram. And you drop a line down like this to get a measurement that's called the height. And you can see it's like it forms a little triangle, but from here to here is the height, and the height times the length of the base of the parallelogram is how you get your area, again in square units. And so for calculating the area of a parallelogram, we don't need to know what these two sides are in length. All we need to know is what the base is, or the longest part of it, and this measurement here called the height. And so on a question, they will give you the height and the base, or they might make you calculate the height. And there'd be ways of doing that, and we'll talk about that later. This other one here is called a trapezoid. And here, notice that the lines are not parallel. This one goes this way, this one goes this way. They're coming together, so they're not parallel. These ones are parallel, so parallelogram. These ones are coming together, so that's not a parallelogram, but it's four-sided, so it's still a quadrilateral. And the area, notice that the base here is not the same for both. There's a shorter piece on the top and a longer piece on the bottom, and we still have this height piece there. So the formula is the area is equal to 1/2 the, what I call B1, or the base of the bottom, plus B2. So you're sort of averaging, these two pieces, and then again times the height, again in square units. And so these are four formulas that you really should memorize, practice doing a few problems, because if they show up, it doesn't take long, and it's a fast, guaranteed point for the question. And so what we'll do is we're now going to do a few problems to illustrate the calculation of area for the square, the rectangle, the parallelogram, and the trapezoid. So let's do an example problem. Area of a square. The test may say something like, what is the area of a square with sides 3 feet and 3 feet? Or it may not even have that. They may just say, what is the area of a square, and label one side 3 feet. You know by definition a square, all the sides are the same length. And so we know our formula for area is 3 times 3, which is 9, and that we're also talking square feet. Square feet. So what might be put in the answers for a question like this? And this would be really common. They would put in the following four answers: 9 feet, 9 square feet, 12 feet, or 12 square feet. And what the reason they put choices like this in, they're seeing if you know the difference between the formula for area and the formula for perimeter, which is the distance around the edge. And do you recognize that you need to have square units rather than just regular units? And so we know from 3 times 3 is 9, and that it's square feet, we would know that one is the correct answer. 9 feet, that's using the 3 times 3 correctly, but not recognizing you need to put the square feet units in place. Now, how about 12 feet? Well, if you were asked what is the perimeter of a square, like if you were marching around the edge, what distance would it be? The perimeter, the outside distance if you were like walking it. Well, it'd be 3 feet plus 3 feet, that's 6, plus 3 feet, that's 9, plus 3 feet is 12. It would be 12 feet. If the question had been, what is the perimeter of a square of 3-foot sides, the answer would have been 12 feet. But they didn't ask that. They asked the area. So you have to read the question carefully and decide, what are they asking me, area or perimeter? And then the number 12, and they put square feet in to try and fool you. Well, maybe you added, maybe you remembered that area needs to be square feet, but you thought you did this by adding each side up rather than by multiplying. And so they would fool you by putting 12 square feet there. So that is a simple question about a square in terms of getting the correct number part right and remembering to use square feet or whatever. If this was yards, it would be square yards. If it was miles, it would be square miles, but square units. So let's look at another problem calculating area for a square that's a little bit more difficult. Here's the question that you might be asked. How much has the area increased when the side of the square increases in length from 4 feet to 6 feet? So let's take a look at that. What they're saying is you start with a square that's 4 feet by 4 feet, and you increase the length of this side by 2 feet and this side by 2 feet. So now you have a square that is basically 6 feet long. And so they're asking, how much has the area increased? And so it's asking you 2 things. Do you recognize three things actually. How to calculate the area of the new square. Second thing, how to calculate the area of the old square. And then realizing if you're going to figure out how much bigger it is, you subtract the old area from the new area. And so this is, again, a question that it would take a little bit longer, but you could still easily do it in about a minute if you recognize the principles. And so let's talk about the area of the 4-foot square. The area of the 4-foot square is going to be 4 feet times 4 feet, which is equal to 16 square feet. This side times this side of this area here is 16 square feet. And then what is the area of the 6-foot by 6-foot dimensions? And that would be that area. I'm going to call that area 1. The second area, I'm calling it area 2 of all of this, is equal to 6 feet times 6 feet, which is equal to 36 square feet. And so how much has it increased? It's gone from 16 square feet to 36 square feet. So it's 36 minus 16. It's increased by 20 square feet. So that would be the answer. How much has the area increased when we make the square 4 feet, add 2 to 6 feet on both sides? It's increased by 20 square feet. Now, how might the test try to fool you. That's the answer it's looking for. One of the choices might be 16 square feet. They just put, that's the area of the first one. They might say 36 square feet, which is the area of the bigger one. Again, making you think, oh, just calculate one of these areas and I'm done. Not seeing if you realize that you have to subtract the two. They might add them together. They might say this is 52 square feet. To see if you realize that you need to subtract the totals, not add them together, and then 20 square feet. So that's how they might pick choices in a question to see if you understand the concepts. They might, so the first one is the area of the original square. This is the area of the big square. But they're asking you how much is it increased, so they're asking you how much bigger is it, and the answer we know is 20 square feet, and they might throw in a choice, you know, did you take this one and add it to this one, because some people might think that's a good idea. And so that is a slightly more difficult type of calculation of area with a square that you could see on the test. So let's look at a slightly more difficult area of a square question that might include algebra that you're expected to know. And so here we have the area of a square. Here's a square, and they say the length of this side is a plus b. What is the area of the square without giving you any actual numbers? Well, remember in algebra, letters just stand for numbers. And so what this question is asking is, they've labeled this length of the square as letters. And so when they say, what is the area of this square, they're asking, do you recognize that the other side is also a plus b, and that the area is one side times the other, which would be a plus b times a plus b. So that's what the area equals. And then remember from using the FOIL method, we can multiply the first terms to get a squared, the outside terms to get ab, the inside terms to get ab, well, ba, but it's the same as ab, and then the last terms, which is b squared. And that if we combine things, we would have an answer of a squared plus 2ab plus b squared. And that would be one of the answer choices. Again, putting together, do you understand these? Do you understand the principle of area, which is one side times the other for a square, and the principle of some basic algebra? And so some answer choices to fool you, you know, they might have the correct answer, a squared plus 2ab plus b squared. They might have something like 2a squared plus 2ab plus 2b squared. I'm just making these up. But they'll see if you expanded this out correctly, and you know, and there could be other ones that have these numbers in front wrong. But that is how they would give you different choices in a question where they're using letters that represent numbers in an area of a square question. And this would probably be the most technical and difficult question you would get on the question of calculating the area of a square on the ASVAB and the GED test. Let's look at another question. This one on the area of a rectangle. So, the area of a rectangle, as we know, is the length times the width, and these two numbers are not the same. If they were the same, that would be a square. And so the area of a rectangle is the length times the width, again, square units. So in this question, we have 4 miles of width. Say this is a big farm field, and I guess an ordinary farm field, and 8 miles of length. So the answer would be length 8 miles times 4 miles is 32 square miles. And so length times the width in square units, 8 miles times 4 miles is 32 square miles. And so, again, part of the way that exams are testing you to see if you're paying attention and know the material is they're checking to see if you've got the number part of the answer correct, and they're checking to see if you're understanding the units that go with it. And so on an exam, there could be things, again, such as, that's the answer, 32 square miles. They might put 32 miles. They might put, see if you've calculated the perimeter. You know, remember the perimeter is the length of walking around the outside. So 4 miles plus 8 miles is 12 miles. And that's and then another 4 miles is 16, and another 8 is 24. So they might put down the answer for the perimeter, 24 miles, and they might see if you're, they might put square miles. So this would be the correct answer for the perimeter. If you're walking around, it's a linear distance, it's just in miles. But here they might say, oh, maybe that you thought that's how you had to get the number portion right, and you remembered that areas in square miles, but you calculated the number portion wrong. And so that's how they might pick some choices to see if you really understand it. They're always looking to see, did you get the number part of the answer right and the units right? It seems like it's not a big deal. You should just be able to put 32 and that's it, and it's no big deal. But it is a big deal, and that's why they put in different units here to fool you. So that's the straightforward area of a rectangle. Memorize this formula. Pay attention to have the right units. Again, it's an easy, fast, correct answer. Some of the math problems you need the full minute to think about. You might have to multiply out some big numbers, and that begins to get tiring. But if you have a question where there's simple answers, you can get it in 15 or 20 seconds without excessively straining your brain and saving your mental energy for the more difficult parts of a test. So let's think about looking at a slightly more difficult area question for a rectangle. So let's look at another question. This is an area of the rectangle question that is slightly more difficult, and that is, the question will say something like, here is a diagram of a rectangle. The starting rectangle is 2 yards, 2 yards by 6 yards. 2 yards by 6 yards. If it increases by 2 yards on one side and 2 yards on another side, how much has the area increased? And again, this is asking, do you recognize that you have to calculate the area of the starting rectangle, the area of the bigger rectangle and then subtract the two numbers to find out how much the area has increased. And so this requires 3 steps. First, to calculate the area of the first starting rectangle. So the area of the first rectangle would be 2 yards times 6 yards, which is 12 square yards. Then it's gotten bigger, and so the new rectangle is 4 yards on this side. It's now 4 yards, and 8 yards this way. It's now 8 yards. 6 yards plus 2 yards is 8 yards. What is the new diameter, the new area? It's 4 times 8, which is 32. Square yards. And how much is it increased? It's gone from 12 to 32 square yards. So it's increased. If we take the area of number 2 and you minus the area of number 1, that tells you how much it's increased, and that's 32 minus 12, which is 20 square yards. Square yards, note the units. So again, the area of a rectangle has they've given you the question that it's increased by 2 yards on each side, and so you have to calculate the first rectangle area, the second rectangle area, and subtract the two. Now, this question could be asked in reverse. This question could say you start with a rectangle that's 8 yards wide and you decrease it by 2. And so it could say you start with 8 and you decrease it by 2. And it could say you're starting with 4 yards and you're decreasing it by 2. How much has the area shrunk? Well, you would calculate it the same way. You take the bigger area, which we know was 32, and the smaller area, which is 12, and you'd say it's shrunk by 20 yards. You do it exactly the same. This question can be written as either you have a triangle that gets bigger or a triangle that gets smaller, but it's the same principles. You need to figure out the area of one rectangle, the area of the other rectangle, and subtract them, and then you just have to make sure you say it has shrunk by 20 yards instead of increased by 20 yards. So that's the area of the rectangle questions. That's not the most difficult question that they can ask about a rectangle. There's some other ways that they'll put a rectangle attached to a triangle, attached to a piece of circle, and they say, what's the area of all of it, or what's the perimeter of all of it? We'll do some questions like that at a later time where they make you be able to use the perimeter and the area of multiple geometric shapes all stuck together. And that would be the most difficult question that they would ask you. And so that is area of a rectangle. All right. Let's take a look at the area of a parallelogram. Now remember, a parallelogram has two sets of lines that are parallel with each other. So these lines are parallel, these lines are parallel. And the formula for area of a parallelogram is this piece here called the height, h, times this long piece on the bottom called the base, or b. So the area is base times height. And so if we multiply that out, it's 9 times 15, which is, oh, did you catch the mistake I made? 135. I did not put squared centimeters. Remember, area is always in square units. Square units. Now, again, straight forward formula, height, base, make sure these are both in the same units. If this was miles and this was centimeters, you'd have a problem. You'd need to make both of them the same unit. And then sometimes on questions like this, what they'll do is they'll give you extra numbers that you don't need for the calculation, just to see if you use them. And so, you know, I've said that this side here is 8. I could have said it's 6. I could have said it's 12. I could have said it's 3. Doesn't matter. You don't need to know the length of this side for the calculation in this case. And so, but they'll see, do you use it? Do you use 8 times 15, which is not correct? And so an incorrect number might be 8 times 15 centimeters squared rather than the 9 times 15 to get 135 centimeters squared. So again, make sure that you're getting the number correct as well as the units. They have to be the same units, square units. For area, square units. Let's look at a slightly more difficult area of the parallelogram question. This is probably about as difficult as it's going to be. Remember, a parallelogram has two sets of lines that are parallel. You know, the top set and the side set. And the formula for getting the area of a parallelogram is the height, this piece here, times the length of the base. The height times the base. But what if they don't give you the height? And what if they give you some other numbers here? What they're asking you to remember is that you can use the Pythagorean theorem to figure out h. And do you remember the Pythagorean theorem? That says when you have a right angle triangle, which is what we have here, this piece here is a right angle triangle, the sum of the squares of the two sides is equal to the square of the hypotenuse, or the long one. And so for this, to figure out x, which is our height that we're looking for, we have to remember that 3 squared plus x squared, and that's what I'm using for height, x, is equal to 5 squared. And so x squared is equal to 5 squared, which is 25, minus 3 squared, which is 9, which is 16. And so if we take the square root of x squared and the square root of 16, we have x is equal to 4. So we figured out that this side is 4 in length. So we figured that out using the Pythagorean theorem that this height here is 4. So now we can use our formula, 4 feet times 15 feet, and that will equal 60 square feet. So 4 feet times 15 feet is equal to 60 square feet. And that is how you'd get the answer. So they would have you calculate the height here in order to use this formula. So they're either going to give you the height and the base and just have you use the formula right away, or they're going to not give you the height and make you calculate the height here using the Pythagorean theorem. So let's look at the area of a trapezoid. It's a quadrilateral geometric shape as well, meaning it has 4 sides. And here the angles are both kind of pointing in to towards each other. And so the area, or the formula for that, is you have to know what the height is here. And you're going to take multiply that by 1/2 the total of these two sides added together. And so that's sort of giving you an average base. You remember in the parallelogram, it was just the height times the base here, because that would have been the same length as this one up here. But in the trapezoid, because these two lengths are different, you're actually sort of taking an average. So you add these two together and multiply it by half. And so the formula is 1/2 the height times the base and the top together. And so in this case, the answer would be 1/2 times 4 times 4 centimeters plus 10 centimeters. 2 times 14, 28 squared centimeters. Remember, you need to get the number correct and the units correct. Always, always, always. And so that's the area of a trapezoid where these two lines are not parallel. And I think one final thought on making sure you get your units correct in an answer. So, some final thoughts on area that are really important to know, and that has to do with keeping your units straight, because there's a couple, I've tried to emphasize the fact that the answer, they care about the number part and they care about the units part. And so you have to look at diagrams and the questions carefully to see if what the units are and if they're the same throughout the diagram, and also to look and see what the answer wants. So suppose they gave you a question that said, here is a rectangle. It is, and it's not drawn to dimension. It's 3 feet wide and 7 yards long. What is the area of that? And so looking at this, you have to realize that in order to get the right answer, you need two things. You need to make sure that the units are the same for each piece. And if they're not, you need to change them. And which one you pick will depend on your answer choices. And so I could calculate the area here quickly by choosing to figure out an answer in square feet. I could also choose an answer in square yards really quickly. 3 feet is 1 yard. 1 yard times 7 yards would be 7 square yards. But that number is based on making sure that yards are both there. Now what if I wanted an answer in square feet? Well, 7 yards is 21 feet. It's the same length. And so then you'd have 21 times 3, which is 63. That'd be 21 times 3, which is 63 square feet. So then you would look to see what your answer choices were. They may give you answers that have square yards and a number, square feet and a number. So the correct answer is either 7 square yards or 63 square feet. And so it's important when you are figuring these out that the length and the width both have the same units, whether it's yards or feet or miles or kilometers or meters, whatever it is, you need to have the same one. And then they may ask you for the answer in a different unit of measure. And so then you have to, you may have to recalculating it using the new measure that they're asking for. So again here, the original question was, you have an object that's 3 feet by 7 yards. 3 feet by 7 yards. If we just multiplied 3 times 7, 21, that would be a wrong number, because the number part of the correct answer is either going to be 7 or 63. And so you'd have to realize right away that you have to make these the same. So either yards times yards or feet times feet. and then get an answer that's either in square yards or square feet. And so that is really important to think about when there are area questions. You may remember the general formula about multiplying one side by the other, but also remember that the units have to be the same, and look in your answer choices to know for sure that you have picked the right units to get the correct answer. If all the answers say we're in square yards, then you'd know you need to convert the 3 feet to 1 yard and then multiply the 1 yard by 7. If all the answers are in square feet, you would need to pick convert everything to feet to figure out the answers. And if God forbid all the answers are a mix, you got some answers in square yards and some answers in square feet, then you got to do the area calculation with both to find out what the correct answer is in square yards and square feet so that you can pick the right one. Anyways, thanks for watching. Dr. Second Chance helping with ASVAB Math and GED Math. Please keep at it, practice, get practice questions, practice doing them, learn to understand the question, and then learn to do it faster, trying to get down to around a minute per question or less. But again, learn to do it right, then learn to do it fast. As they say sometimes slow is smooth and smooth is fast. You know, get it right and then worry about the speed. Anyways, we'll see you next time as we talk about some other area problems that could be on there and review perimeter questions as well.